Prudent Scholars in association with Goa Headmasters Association.
Hello students, welcome back to the lesson carbon and its compound. In the last class we learnt about the bonding in carbon, that is covalent bonding, and how the small size of carbon gives it a unique stability compared to the other atoms. We also learnt about the versatile nature of carbon due to the self-linking property which is called as catenation. We learnt about the tetravalency, okay, that is because of the tetravalent nature of carbon, how the carbon atom bonds with various other atoms, not only with carbon but also other atoms. And we also learned how the multiple bonds, that is formation of double bond and triple bond in carbon, gives rise to various kinds of compound, from straight chain to branch chain to ring shaped structures. So these are the variety of compounds that we are formed because of these reasons. Now besides that, last class before we ended we started with hydrocarbons. Okay, so let us have a brief revision about it. Now you can see hydrocarbons, the compounds which are made up of hydrogen and carbon are called as hydrocarbons. Now hydrocarbons are of two types, open chain or aliphatic or acyclic hydrocarbons, and closed chain cyclic or ring hydrocarbons. Now open chain or aliphatic or acyclic hydrocarbons are divided into saturated and unsaturated. In the last class we learned saturated hydrocarbons are those in which the carbon atoms are linked via a single bond, and unsaturated hydrocarbons are those in which the carbon atoms are linked via either double bond or triple bond. Saturated hydrocarbons are also called as alkanes. Unsaturated hydrocarbon, those possessing double bond are called as alkenes, and those possessing triple bond are called as alkynes. Okay. Now regarding the closed chain or cyclic or ring hydrocarbons, they are divided into two wide categories, that is alicyclic hydrocarbons. Now what are alicyclic hydrocarbons? Those structures or those rings, the closed rings which do not have any double or triple bond, like cyclohexane, cyclopentane, all the cycloalkanes will come under this category. Okay. So you name it, like cyclopropane, cyclobutane, all the ones which are ending with ane, that means they are linked via a single bond, they will come under the alicyclic hydrocarbons. Whereas the aromatic hydrocarbons, the name itself is aromatic. So when the compounds were being discovered, these were the sweet smelling compounds. Okay. So aromatic hydrocarbons are those which are having a fused benzene ring, that is C6H6. There was a question that had come during the boards, I think in 2017, wherein the structures were told to be drawn of cyclohexane and benzene. Remember, one of them is alicyclic and the other one is aromatic. So in case of cyclohexane, there is absence of double or triple bond, but in case of benzene, okay, it is containing a benzene ring with alternate single and double bond. So you can see the alicyclic are cycloalkanes. Here is an example of cyclohexane C6H12, and those with aromatic are those containing the benzene ring with double or triple bond. So this is what we learned briefly, and also we learned the general formula of alkanes, that is CnH2n plus 2, alkenes CnH2n, and alkynes CnH2n minus 2. Fine. So let us quickly revise the functional group that we have learned. Okay. So what is exactly a heteroatom? Hydrogen can be replaced in a carbon compound by any other atom, say sulfur, nitrogen or halogens. Okay, so these are called as heteroatoms. So here are the heteroatoms given to you: chlorine or bromine, oxygen, nitrogen, and the names of the functional group are given over here. Alcohols, OH, halogens, chloro, bromo, ketone, C double bond O, carboxylic acid, C double bond OOH, ester, C double bond OOR, amino, NH2 and nitro, NO2. Now you can see in the functional group there is some single line, there is a dash which is being put. Now that dash represents the free valency of that particular functional group. So if the functional group has to get attached to the main compound, it is going to get attached via that dash. That dash represents through which the bonding is going to get the bonding is going to take place to the main compound. Okay, and that is the suffix use. Now what is the suffix? Suffix is something that is used at the end and prefix is something that is used in the beginning. Now if you look at the functional groups on the screen on the last column, you will realize in case of halo groups, that is the halogens, okay, the prefix is used. That means the halogens, in case of halogens, suffix is not used. So chloro will be used before. Chloro will not be used at the end. Okay. So only halo groups are named as prefix, whereas the other ones, that is alcohol, aldehyde, ketone, carboxylic acid, esters, amino, nitro, all these groups that you can see, okay, except for amino and nitro, till esters from 1 to 5 they are being used as suffix, that is their name is going to come at the end. Okay, and amino and nitro they are being used as a prefix. This much you have to understand before we begin with the nomenclature. Okay. Now before we start with nomenclature, we need to understand what exactly is homologous series. Now homologous series, it is a series of compounds in which the same functional group substitutes for hydrogen in a carbon atom. We know carbon is tetravalent. Okay. Carbon is having 4 hydrogens attached to it. If either one of the hydrogen gets replaced by any other atom, either halogen, either nitrogen or oxygen or sulfur, so this atom which will be getting replaced is called as a heteroatom. So in this case you can see, in case of homologous series, the series is going to consist of the same functional group. Now for instance, if you are having alcohols, the functional group will be OH. If it is aldehyde, the functional group will be CHO. So the successive member differs by 1 CH2 unit and 14 units of mass. So every functional group, when you go below the series, you will realize when you move from one compound to the other, they are differing just by CH2 unit, and the mass difference between these two is by 14, which we will see soon. Okay. Now what is most important about this homologous series is that the chemical properties are imparted by the functional group. We already have learned that a functional group is either an atom or a group of atom which when attached to a compound changes the property of the compound. So in case of homologous series, you know it will contain the same functional group throughout. So the chemical properties which are imparted by the functional group are going to be same. That means the chemical property in the homologous series is not going to change. Okay. But the members have different physical properties. Now when I talk about physical properties, maybe the melting point, the boiling point, okay, these will differ. So the physical properties in homologous series will change, but the chemical properties are going to remain the same throughout. The physical properties vary among the members of homologous series due to difference in their molecular mass. Okay, as you go down the homologous series, what is going to happen? There is going to be increase in the mass by 14 mass units. So this increase in molecular mass changes the physical property of these compounds present in the homologous series. Now melting and boiling point increases with increasing molecular mass. Why will the melting and boiling point increase with increase in molecular mass? Because now the molecules are becoming bulkier. Besides that, the bonding is increasing. So in order to break the bond, enough energy has to be supplied. So more the energy, higher will be the boiling point or the melting point. So let us look exactly how the homologous series look like and what exactly is, how exactly do they differ by the CH2 unit. Okay, so you can see over here, these are examples of 3 alcohols, that is methanol, ethanol and propanol. Now you see all of them are ending with the suffix all. Okay, this is the first thing that you have to note. Now second thing, if you see, if you are moving from CH3 to C2H5OH, how many carbons are less? There is 1 carbon less. And how many hydrogens are less? There are 2. So there is 1 carbon which is less and number of hydrogens that are less are 2. So here there is 1 C, over here there are 2 carbons, here there are 3 hydrogens, here there are 5 hydrogens. So when you are in the homologous series, you can see that when you move from one compound to the next, okay, in a series, they differ by a CH2 unit. Fine. And the difference in their mass, as I have explained to you earlier, is 14 mass units. What is the atomic mass number of carbon? It is 12, and the atomic mass number of hydrogen is 1. Since there are 2 hydrogens, we are going to write 2, and the total mass number is 14U. So you see, when you are moving from one compound to the next, they differ by 14 mass units. So in a homologous series, okay, all the 3 are alcohols only. All of them belong to the family of alcohols: methanol, ethanol and propanol. They all have the same properties, chemical properties, but they all have different physical properties. Okay. So here are some more examples of alkenes, alkynes and alkanes. So you can see methane, ethane, propane. All of them belong to the family of alkanes. Okay. But they are differing to each other by a CH2 unit and 14 mass units. And in case of alkenes, you see ethene and propene again, they belong to the same family of alkenes. Okay, and then we are having alkynes, ethyne and propyne. So students, such series in which you can see in which the functional group, okay, is same and the chemical properties are same, they are called as homologous series. Now what are the characteristics of homologous series? As we have already discussed, the successive members in homologous series differ by CH2 units or 14 mass unit. Okay, members of given homologous series have the same functional group. Also note down students, double bond and triple bond, also when they are present in a compound, they change the property of compound. So you might think that only alcohols, carboxylic acid or ketones are those who will change the property of the functional group. It is not so. Double bond and triple bond, these are also functional groups which when present in a compound changes the property of a compound. So let us come to how exactly I am saying ethane, propane, methane. I am using these terms. So from where exactly have these names come? So these names were given after the source from which the organic compounds were first isolated. Okay, this is the trivial system of nomenclature which has been slightly modified now and it is being used in order to name the various carbon compounds. So the names were given after the source from which the organic compounds are first isolated. For example, if a compound has one carbon atom, then its common name will have root word and so on. So you can see in the table over here, if the number of carbon atoms is 1, then the root word is the word from which the compound was first derived. Okay, so if the number of carbon atoms are 2, then the root word is acid, 3 then propion, butyr, valor and so on. So this is a trivial system of nomenclature. Okay, but now it is being modified. Okay, so over here you can see you have to first learn this, you have to first understand this clearly in order to write the names of any given compound that is given to you. So now let us focus on this. Over here you can see it is mentioned chain length. So chain length is being decided by the number of carbon atoms that are present in a compound. Okay, if there is one carbon atom, it is written as C1. If there are 2 carbon atoms in a compound, it is written as C2, 3, C4, C5, C6 and so on. The word root or the root word for when there is one carbon atom, the word root is meth. When there are 2 carbon atoms, the word root is eth. 3 carbon atoms prop, 4 carbon atoms but, 5 carbon atoms pent, 6 carbon atoms hex. If there are 7 carbon atoms, it will be called as sept, 8 carbon atoms oct, 9 carbon atoms non, 10 carbon atoms dec and it goes on. So the words that I am pronouncing over here, meth, prop, eth, these are called as word roots. Okay. Now let us see how these word roots help us in the nomenclature. Now what exactly is nomenclature? Nomenclature is a system of assignment of names given to organic compounds. In hydrocarbon chain, one or more hydrogen atom can be replaced by other atoms in accordance with their valencies. The element that replaces hydrogen is called a heteroatom, and these heteroatoms and the group containing them, they impart chemical properties to the compound and hence are called functional groups. So you can see there are various compounds over here which are being shown. So over here you can see a carbon Okay, this is an alkane which is having 4 hydrogen atoms linked to it. If either one of the hydrogen is being replaced by any other atom, we will call it as a heteroatom. These are few examples of the functional groups which we have already done before. So, who decides the naming of these organic compounds? So that these compounds are having the same name throughout, everywhere, so that everyone is familiar with the names that we use. The responsibility of giving this name was decided by iupac, that is International Union of Pure and Applied Chemistry. Okay? So let us go through the 5 important rules of iupac in order to name the organic compound. First important step, you have to identify the number of carbon atoms and write the word root corresponding to it. We have already learned before and you have to learn it. You have to learn the word root from C1 to C10. Okay. Then presence of a functional group is indicated by prefix or suffix as given in table 2. So you know, students, what you have to do next is, besides learning the word root, you also have to practice writing the names of the functional group along with their suffix, along with their symbol and along with their names. Okay, so alcohol, OH, all. Carboxylic acid, COOH, oic acid. So you need to learn it that way. Fine. So why you have to learn it? Because if you are given a compound and you are told to identify a functional group, you should be able to do it. If the name of the functional group is to be given as a suffix, what is the meaning of suffix? The last, okay, suffix means what? Something that you use later on. Prefix, that is something that you use before. So for example, in general I will just tell you, okay, suppose there is a name called as Ritik Roshan. Roshan will be suffix because it is being named later on, okay. So that is the meaning of suffix. So in a compound also, the suffix has to be named later on. So if in case the last letter E in the name of the compound is deleted and the suffix is added, example, a ketone with 3 carbon atoms need to be named as propane minus E. So if there is an alkane and there is a functional group, you need to drop the letter E from your alkane because 2 vowels cannot be together. Fine. Then halogens in iupac are written as prefixes. Also amino and nitro groups are written as prefixes, and compounds with 2 carbon atoms and 1 chloro group is named as chloroethane. So now let us look at the examples how exactly we have to write the iupac nomenclature. So before we start writing, let us see functional group. What is the suffix for alkene? In. Suffix for alkyne is ine. For alcohol is all. Aldehyde is al. Ketone is on, carboxylic acid is oic acid, and chlorine is said as chloro, which is a prefix. Okay. We have learnt earlier, suppose I am having 2 carbon atoms. Over here you see, students, the 2 carbon atoms are linked via a single bond. Now second question you need to ask yourself, is the tetravalency of the carbon satisfied? If you see, no, we already know that carbon should have 4 bonds around it. So this one is having 1, 2, 3, 4. So in case of carbon number 1, the tetravalency is satisfied. What about carbon number 2? Okay, here there is only 1 bond. So how many bonds does it require? 3 more bonds. Okay, we will replace it with hydrogen over here. So you see, in this particular example, what is the word root? Since there are 2 carbon atoms, okay, 1 and 2, if there are 2 carbon atoms, then the word root is eth. Okay, and next you see all the atoms, hydrogen as well as carbon, they are linked to each other via a single bond. Since they are linked to each other via a single bond, we know it is an alkene. Okay, so what is the suffix we are going to use? You are going to use the suffix "ane". So over here you are going to name it as eth, which is your word root, okay, and your suffix, that is "ane". Fine. Let us see another example. Suppose I am having 2 carbon atoms, but in this case the 2 carbon atoms are linked to each other via a double bond. So in order to satisfy the tetravalency of carbon, we see that 1, 2 and how many bonds more are required? There are 2 bonds more required for the tetravalency of the carbon to be satisfied. So I will put 2 more bonds, and same thing in the other case. So now I am having 1, 2, 3, 4, 1, 2, 3, 4. We are not going to put any more bonds because carbon is tetravalent in nature. Next I am going to put hydrogen when nothing is written. So now over here you can see, students, there are 2 carbon atoms. Again the word root is eth. But what is the suffix that we are going to use? Since there is a double bond between 2 carbon atoms, we know it is not an alkane but it is an alkene. And the suffix that we will be using is going to be E and E. Okay, and the name will be eth, ene. Okay, let us take the third example. In the third example, let us put 3 bonds between the 2 carbon atoms. Okay, now 1, 2, 3, we know that carbon requires 1 more bond in order to satisfy its valency. So we are going to put dash and we are going to write H. So now we see 1, 2, 3, 4. 1, 2, 3, 4. So the tetravalency of carbon is satisfied. Since there are 2 carbon atoms, again the word root is going to be eth. But this time there is a triple bond. Now since there is a triple bond between them, we know it is an alkyne, and the suffix that we are going to use is going to be ine. So in this case the name of the compound is going to be eth ine. Okay. This is a very simple example for you to understand. Now one thing that you will notice, students, we do not have methane, we do not have methane. Can we construct a structure? Because meth, we know C1 is meth. When there is 1 carbon atom, the word root is meth. Can we get an alkene and alkyne from meth? We cannot get, because a double bond or a triple bond is formed between 2 carbon atoms. If there is just 1 carbon atom, then we cannot call it as methane or methane. So please take a note, students, methane or methane does not exist because a double or triple bond is not there, because there are no 2 carbon atoms. So in order for a double or triple bond to be formed, the minimum number of carbon that is required are 2 carbon atoms. So next example, let us see. Over here you can see, student, this formula that I have written is similar to this formula. This is called as a condensed formula, while this is called as a structural formula, because I am showing you every atom with the help of bond. So here if I ask you to name the compound, you are going to first see how many atoms of carbon are there. So there are 2 carbon atoms. Take a note, students, chlorine is Cl, but C is not considered as carbon. Okay. Chlorine is a functional group that is being attached. So if I tell you to identify the functional group present in this particular compound, your functional group is chlorine, or a halo group which is being written as chloro, okay, and which is being used as a prefix and not a suffix. Okay. Now since there are 2 carbon atoms, we know the word root is eth. Okay. And the functional group present is chloro. Now over here what has exactly happened? Okay, these are my hydrogen atoms, CH3, so 1, 2, 3, CH2, 1, 2, and one of the hydrogen which was there over here got replaced by chlorine. So that is my heteroatom which is getting replaced. So over here you see the structures 1 and the structure 2 both are same. This is a condensed structure and this is a structural formation that is being shown. So how would we name this compound? In case of whenever your functional group is a halo group, you are going to use a prefix. So now we are going to write it as chloro. And how many carbons are there? Since there are 2 carbons and all are linked via a single bond, we will be calling it as chloroethane. Okay, students? So in the previous example you saw chloroethane. So one formula that you can remember, it will be easy for you to name the compound. Whenever a functional group is having a prefix, you are going to write the prefix first, followed by a word root, followed by the suffix. Let us take another example. Okay, so over here we are having CH3, CH2, CH2, Br. Your first step is to count the number of carbon atoms. Okay, so 1, 2 and 3. So how many carbon atoms are there? 3 carbon atoms. Since there are 3 carbon atoms, your word root is going to be prop. Okay, and the functional group that is present over here is your bromine, which is another halo group. So which will be used as a prefix. Okay, so what I am going to write? I am going to write bromo. What is the word root? 3 carbon atoms, so bromo, prop. Since all are linked via each other through a single bond, I am going to call it as bromo-propane. So my word root, my prefix is bromo, my word root is prop and the suffix is -ane. Okay, very simple. I am teaching you side by side how to write the structure as well as how to name the structure. Let us take another example. Okay, so this is another example. Again, your first step, if you want to name the compound, you are going to count the number of carbon atoms and count it in such a way that you get the longest chain. Do not consider the carbon from chlorine, I repeat again. So we are going to start numbering. The lowest number will be given to that particular carbon which is being attached to a functional group. So over here you can see the functional group present is chlorine, which is attached to this particular carbon. So rather than numbering 1 from over here, I am going to start numbering 1 over here, because the rule says, iupac rule says that the lowest locant is the number. The term used for a number is locant. Okay, the lowest locant will be given to that particular carbon which is being attached to a functional group. So I am going to start numbering 1, 2, 3 and 4. So if there are 4 carbon atoms, what is the word root? Yes, you get it right, it is but. Okay, so we know word root is but. We know a prefix. What is our prefix? Since chlorine is attached, our prefix will be chloro. Okay, so I am going to name it as chloro. There are word root is what? 4, so but. All are linked via a single bond, so it is going to be called as chlorobutane. I hope this is clear to you all. Let us move on to our next example where we will take another functional group. So in the second example, again I have given you 2 structures. One is that of condensed and another one which we are going to write the structural formula. So in the first case, first to identify what is the functional group present over here. Okay, so you see the functional group present over here is CO. Okay, CO is your ketone group. Okay, ketone can be written as CO or it can be written as C double bond O. Now if you look at the functional group that is being written, there are 2 dash across the carbon atom. What does the dash show? The dash shows that it is a free valency. So it is going to get bonded to a carbon compound via its free valencies and thus become stable. So over here you see I am having, now remember students, in case of ketone, the carbon of ketone is considered, unlike that of halo group chlorine. Okay, so we are going to start numbering the compound 1, 2 and 3. Now we know that the word root is 3, that means it is a prop. Now if I want to draw the structural formula for the same, I am going to write CH3. Okay, over here it is CO, so I have not put CO, rather I am going to write it that way, C double bond O. So this is your ketone group which is linked to the 2 other carbon atoms followed by hydrogen. Okay, so again if I want to number this, since it is a symmetrical structure, I can either number it from left or right. So I am going to put 1, 2 and 3. So in case of ketone students, we know it is not the prefix that we use, but we use the suffix, and the suffix used is -one. Okay, so in this case we do not have a prefix, so we will not consider that. Now we have the word root, as prop. Now you see each carbon atom is linked to each other via single bond. So we can see we are having an alkane, okay, and we are having a ketone group. As I told you, the rule states that 2 vowels cannot be together. So we have to drop the E from the alkane. So the alkane that we are having in the group is propane. Okay. So I am going to minus the E. Okay. And the ketone suffix is O and E. So what I am going to do, I am going to cancel the E from the alkane. So the alkane that is present is prop and I am going to join O and E. Fine. So what is the name of the compound that is over there? It is propanone. So 1, 2, 3, the word root is prop. The suffix used is on and hence the name of the compound is propanone. Clear to you all? So as the functional group changes, so what you need to know, which functional group you are going to use the suffix and which functional group you are going to use the prefix. Let us take another example. Okay, so the next example that we have, okay, we'll start counting. First we'll identify what functional group is there in the given compound. The functional group that is present over here is CHO. CHO is an aldehyde, also written as, we already know students, aldehyde. Okay, it's either written as CHO or it is written as C double bond OH. And we use the suffix for aldehyde that is called as al. Remember, the carbon of aldehyde has to be considered. So when we start numbering, we are going to start numbering from where the functional group is being attached. So the lowest locant will go to the carbon of the functional group. So I'll start numbering 1, 2, 3, 4 and 5. Now how many carbon atoms are there? There are 5 carbon atoms. Since there are 5 carbon atoms, the word root is pent. Okay, so I am not having a prefix over here, but I am having the word root as pent. Since all are linked via a single bond, I know it is pent in. Yes or no? And my suffix that I have to use is al. Now E and A are the two vowels. So what I am going to do? I am going to drop E from pentane and I am going to attach the suffix al. Okay, so what is the name of the compound that I get now? Pentanal. Okay, so 1, 2, 3, 4 and 5 is my word root pent and CHO is the aldehyde group having the suffix al. A very simple and very easy method to name the carbon compounds. This is about naming, and you see even when you write, suppose let us take another examples where I will write the name of the compound and wherein you can draw the structures. Okay. So over here you see, let us try to write the name butanoic acid. So when we want to write the structure of butanoic acid, first we need to know what is the functional group, what is the word group, whether we are going to use a prefix or we are going to use the suffix. So from the name itself you come to know how many carbon atoms are there. If the word is having but in it, we know there has to be 4 carbon atoms. So immediately without thinking anything, what you can do is you can draw the skeletal structure. Okay, so we know that there is going to be a single bond present between the 2 carbon atoms. So what is being done? Each carbon atom is linked via a single bond. But is the valency satisfied is the second question that you need to ask yourself, because we know carbon is tetravalent in nature. So you look at each carbon, you see, okay fine, there are just 1 bond present or there are just 2 bonds present, and accordingly how many bonds I am going to add on to the structure. And since it is, you see it's oic acid, that means you have to think what is that functional group that is having the sound oic acid. Yes, it is carboxylic acid. So carboxylic acid is written as COOH or it is written as C double bond OOH. Now many a times students, you often do mistakes when you write the structure of aldehyde and when you write the structure of carboxylic acid. The structure of aldehyde is C double bond OH. I am going to write it down over here for your knowledge, C double bond OH. This is the structure for aldehyde. And this is the structure for carboxylic acid. Do not get confused between these two structures. In this particular structure it is C double bond OOH and in this particular structure it is just simply H, there is no O. Now another thing that you need to know, carboxylic acid as well as aldehyde that get linked to the main carbon chain via a single bond, that is the free valency that is being available. So now let us not focus on aldehyde because we are going to write the name of carboxylic acid. Since we know it's but and we have drawn the skeletal structure of carbon, next we need to accommodate oic acid, that is carboxylic acid. What you need to know is carbon from carboxylic acid is being counted. So one of the carbon I am going to write it as COOH. Okay, I am writing a condensed formula. So COOH is already being written over here. So next what I am going to do, I am going to try to satisfy the valency of the carbon. So when I put H over here everywhere, I am getting, let's start counting the number of carbons, 1, 2, 3 and 4. I am having 4 carbon atoms. Okay, so but is my word root, oic acid is my functional group, and here I have drawn the structure of butanoic acid. A very simple, sometimes it is asked for exam for 1 mark to draw the structure, or you are asked name the functional group that is present in the given structure. Okay. So next let us try to name a compound containing a double or triple bond. Okay, first let us try to name the compound and then let us try to draw the structure. Fine. Suppose I am having the compound. So you see over here students, the carbon chain that I am having, it's not only constituting of single bond but it is also having a triple bond in it. You know that double or triple bond also acts as a functional group because now the presence of it is going to change the chemical property of that particular compound. Also remember, we are going to start numbering from that particular carbon where there is the presence of double or triple bond. So we will start numbering from here, 1, 2, 3, 4. Since there are 4 carbon atoms, we know it is butane, but we see that at number 1 position there is a triple bond that is being attached. So what is the suffix that you are going to use? The suffix that you are going to use is going to be "-ine". Okay. So what is going to be the name of this particular compound? It is but. Okay. And since there is a triple bond, it is going to be an alkyne and it has been called as but-ine. Let us take another example. Suppose I want to draw the structure of pentene. Okay, to draw the structure of pentene, the number of carbon atoms, pent means how many carbon atoms? There are 5 carbon atoms. So what I will do, I will draw the skeletal structures of 5 carbon atoms and I know there is my suffix that is ene. So somewhere, since the number is not mentioned, it is just mentioned as pentene. So at number 1 position there is a double bond. So if I put a double bond over here and then what I do, I have to try to satisfy the tetravalent nature of carbon. So 1, 2, how many bonds do I require? 3 and 4. 1, 2, 3, 4. Okay. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. See how you have to put dash, that is the number of bonds, by counting the tetravalency of the carbon. So now I am going to write the hydrogens. So students, if you see, I have drawn the structure of pentene. So I will start numbering 1, 2, 3, 4 and 5. There are 5 carbon atom and E, that is a double bond, is connected to the first carbon atom. So these are the various ways in which you have to name the carbon compound, but most important that you have to remember the sequence prefix plus word root plus suffix. Okay, so let us have a brief revision. So example, those containing double bonds, you see word root plus in, butene, ethene are the examples which are over here. Next, having the triple bonds, you see in the carbon here there is a triple bond near the first carbon. So ethyne, butane. When there is a halo group that is being attached, prefix is being used. Bromine also prefix is being used, bromomethane. Okay, over there another example on the other side you can see that is consisting of double bond. We are having propene, propyne. So students, what you need to understand from this is you have to learn, okay, you have to learn the functional group. You need to know for which particular functional group you are going to use a suffix. You need to know the formula of those functional groups. You have to know if there is a double bond or triple bond present, what suffix you are going to use for the same. So here are more examples: alcohol, ethanol, aldehyde, ethanol, ketone, propanone, carboxylic acid, methanoic acid, and so on. So these are some of the compounds whose nomenclature we have already learned. So I hope IUPAC nomenclature is simple and you have understood how it has to be done. So students, hope now you know what is homologous series and how the properties differ in homologous series, only the physical properties, how they differ. Also we have learned how to name a compound using International Union of Pure and Applied Chemistry nomenclature, so IUPAC nomenclature. We have followed the rules of IUPAC nomenclature and we have learned how to not only identify functional groups, we have also learned how to draw the structure of the given compound. So I hope you all have understood today's class, which is very important. Please revise about the names of the functional group, revise the word root C1 to C10, okay, write it down and see you for the next class wherein we will be learning about the chemical properties of carbon compounds.